Which of the following is an empty set? X square minus 1 is equal to 0, x square plus 1 is equal to 0, x square minus 9 is equal to 0, x square is equal to x plus 2, where x is a real number, right? So let's see the answer for this. Taking option A, we have x square minus 1 equals 0, where x is a real number, which means x belongs to real number set. X belongs to R. R. So, which implies x square equals 1, right? So, x is equal to plus or minus 1, which belongs to real number. So, no problem in option A. So, taking option B, we have x square plus 1 equals 0, which implies x square is equal to minus 1, where x is equal to root of minus 1, which is not defined. So, when it is not defined, it becomes an empty set. So the option is B, so we can neglect option C and D to save our time in CET. So option B. Thank you. Question 2. In a group of 75%, everyone takes either tea or coffee. If 45 take tea and 35 take coffee, then the number of persons who take tea only is. Your options are A 35, B 40, C 45 and D 50. So answer is the number of persons taking tea. Yes, let's say it is n of t, right? T is equal to n of t. Number of persons taking tea is equal to n of t. Number of persons taking coffee is equal to n of c. We know that n of t plus n of c is equal to n of t union c plus n of t intersection c, right? And we are given that n of t union c is equal to 75, right? And n of t is equal to 45 and n of c is equal to 35. Sorry, that should be 35. So by the formula we have 45 plus 35 is equal to 75 plus n of t intersection c, right? So 45 plus 35 is equal to 80 minus 75 is equal to n of t intersection c. We get 5 is equal to n of t intersection c. So number of persons taking t only, n of t only, right, is equal to n of t minus n of t intersection c. So we get 45 minus 5 is equal to 40. Now we should just match the options. Option B, right? It is option B, yes. So let's move on to the next question. Two finite sets A and B have m and n elements. If the number of subsets of A is 1, 1, 2 more than that of B, the values of m and n are. So now your options: A is equal to 4, 7, B is equal to 7, 4, C is equal to 4, 4, D 7, 7. So to answer this question, it is given that two sets A and B have m and n elements each. A has m elements and B has n elements, right? We are given that number of subsets of A is equal to 112 plus the number of subsets of B. Subsets of B. So, which implies 2 to the power of m is equal to 112 plus 2 to the power of n, which also implies 2 to the power of m minus 2 to the power of n is equal to 112. Taking 2 to the power of n common, we get 2 to the power of m minus n minus 1 is equal to 2 to the power of 4 into 7, which is nothing but 112, because 16 into 7 is equal to 112. So, equating LHS and RHS like this way, we get 2 to the power of n is equal to 2 to the power of 4, which implies n is equal to 4, and 2 to the power of m minus n minus 1 is equal to 7, 2 to the power of m minus n is equal to 8, 2 to the power of m minus n is also equal to 2 to the power of 3, which is 8. So m minus n is equal to 3, m minus 4, by the value of n we get is equal to 3, m is equal to 7, which is in the given options option B. Thank you. A is equal to 2 comma 3 comma 4 comma 5 and B is equal to 1 comma 3 comma 4, and R is a relation, is a divisor of on A into B, then R is, your options are 4 comma 2, 4 comma 4, 3 comma 3, 2 comma 4, 4 comma 4 and 3 comma 3, 3 comma 4, or 2 comma 3 and 2 comma 1. So, to solve this, we are given A is equal to 2 comma 3 comma 4 comma 5 and B is equal to 1 comma 3 comma 4. R is a relation, is a divisor of from A into B. So now take option A, right? In option A we are given 4 comma 2, 4 comma 4 and 3 comma 3. Here 4 comma 2, right? 4 is not a divisor of 2. Divisor of 2, yes. So option A is ruled out. So next, option B. Taking option B. Option B is given as 2 comma 4, 4 comma 4 and 3 comma 3. Here 2 is a divisor of 4, 4 is a divisor of 4 and 3 is a divisor of 3, right? So option B is the right option. So you can mark the answer blindly as option B by not considering option C or D. So neglect that. So it saves time. If A and B are two sets such that n of A is equal to 30 and n of B is equal to 41, then n of A union B is options equal to 71, less than 71, greater than 41, or less than 41. So, to solve this problem, we are given that A and B are two sets where n of A is equal to 30 and n of B equals 41. So n of A union B equals question mark. Is it? So we have to match it with the options afterwards, right? So remember always what and this formula is very very important. Remember it for CET. N of A plus N of B minus minimum of N of A and N of B. The minimum of the values of N of A and N of B is always less than or equal to N of A union B. Right? This is a very very important formula. You have to remember this for CET. So, which implies 41 plus 30, 30 plus 41 minus minimum of 30 and 41. Sorry, 30 and 41 is always less than or equal to N of A union B. Right? So, 30 plus 41 minus 30 is always less than or equal to N of A union B. Here minus 30 plus 30 gets cancelled, 41 remains. So we conclude that N of A union B is greater than or equal to 41. Implies N of A union B, yes, as I told, is greater than or equal to 41. Right? So option is B. Fine. Oh, sorry, it's option C.